The second type of speed we want to look at is angular speed. And angular speed is measuring how quickly an angle changes. How quickly an angle changes. So for example, I might want to look at an angle that starts right here, that is a 0 degree angle. And if it takes me 10 seconds to get to a 75 degree angle, what is the speed of angle change per second? And the answer you can see to that is if I have 75 degrees and I divide it over 10 seconds, then it's going to be 7.5 degrees per second. So what I'm concerned about here is how quickly does the angle change? Now, the nice thing about angular speed is that I don't care how large the circle is. This radius here could have been 1 inch. This radius could have been 1 mile. And all I care about, though, is this angle change. How quickly does it change? If I had a radius of 1 inch and the angle changes 75 degrees in 10 seconds, my angle measurement is 7.5 degrees a second. If my angle here were 100 miles long and it takes 10 seconds to get 75 degrees, the angle measurement is still 7.5 degrees per second. But if you think about it from a logical perspective, if I were to have something that is, say right here, and I say this is going to be 1 inch, the distance it covers is going to change. So if I were to look at the linear speed does increase based off of how far out on my radius I go. Angular speed doesn't care about that. All I care about is how quickly this angle is changing. So that's a big difference between angular speed and linear speed. Angular speed only cares about how the angle changes, whereas linear speed is going to take into account how far out you are, because you've got a certain distance that you have to cover, and the larger your radius, the larger that intercepted arc distance is going to be. So angular speed, we're looking just straight at angle measurement divided by time. So let's look at our notes, and we're going to look at angular speed. Angular speed is how fast an angle is changing in a given amount of time. And it's almost always found in radians per second. So just like we had a special factor for linear speed, we're going to have a special factor for angular speed. And the angular speed factor is going to be 2 pi radians over 1 revolution, or 1 revolution over 2 pi radians. And the reason for that is because a full revolution, or a full time around the circle, is 2 pi radians, or 360 degrees. So 2 pi radians and 1 revolution mean the same things. If you compare the two formulas from linear and angular speed, the only difference is the word radians versus radius. Radius has no place with an angular speed. Radius is linear speed. However, the angle measurement, which is radians, goes with the angular speed. So right here, how important is it to find the radius in these problems? It's not important. All we care about is how the angle changes. So we want to find the angular speed of the tip of the minute hand of a watch in radians per second. So we're looking for angular speed. So I know I'm going to use this 2 pi radians over 1 revolution. And we're also going to use the minute hand of the watch. Now, there's one unwritten measurement in here that isn't listed, And it's the fact that we're using the minute hand of the watch, and the minute hand is going to make one revolution in 60 seconds. So that's going to be the one piece that we have to include in this, one revolution in 60 seconds. So we're looking at angular speed, and I know my angular speed is going to be in radians per second. So let's start with our radians over revolutions. So 2 pi radians over 1 revolution. Now the next piece that I know here is the minute hand of the watch makes 1 revolution in 60 seconds. So 1 revolution over 60 seconds. Revolutions cancel out, and I've got radians per second. Is that right? No, it's not. Because I am looking at the minute hand of a watch. And if I'm looking at the minute hand of a watch, it's going to take 60 minutes to rotate. So here, this is 1 revolution is actually 60 minutes. So you got to make that quick switch right there. Radians per minute, that's not quite radians per second. So I've got to go one step further and say 1 minute is 60 seconds. So minutes are going to cancel. Now I've got radians per second. And if I plug that into my calculator, I get approximately 0.002 radians per second. So a minute hand actually makes a revolution in 60 minutes, not 60 seconds. So we do need to make sure our measurements are right for that. The second example, find the angular speed in radians per second of a point on a gear turning at the rate of 3.4 revolutions per minute. Once again, we're looking at angular speed. And right here is a great starting point, 3.4 revolutions per minute. That gives me an exact value that I want to start with for a factor. So let's start 3.4 revolutions per second. And I want to find the angular speed in radians per second. I did it again, revolutions per minute. This should be over minute. Revolutions per minute. And I want to find radians per second. So I need to start by doing 1 minute over 60 seconds. And then I'm going to use my angular speed. I've got revolutions per second, but I want radians per second. So I know that 1 revolution is 2 pi radians. So my revolutions cancel out, and I can multiply across the top 3.4 times 2 pi and divide that by 60, and I come up with approximately 0.356 radians per second. Now, if you compare these two problems, you might look at the first one and say, well, how did I know to start with 2 pi radians over 1 revolution as opposed to 1 revolution over 2 pi radians? The second example, it gave me specifically 3.4 revolutions per minute, so it gave me a direction to start with my units. But this one, I didn't have that. And this really comes down to a logic problem. 2 pi radians over 1 revolution. Since I already have radians and I want radians per second, I know that I'm not canceling radians anywhere. So radians per second means radians has to be in the numerator, so I started with radians in the numerator there. Some of you might jump and say, you know what, if I know my minute hand takes 60 minutes to make 1 revolution, maybe I want to do 60 minutes over 1 revolution to start off as a starting point. But then if I do that, I'm going to have my revolutions and radians in the wrong spot, and then I won't end up with radians per second. I would end up with seconds over radians. So we've got to make sure that our units are right. Radians, the only one that we have that's the only factor we've got that uses radians is 2 pi radians over 1 revolution. So that's why we started with 2 pi radians over 1 revolution. We wanted radians to be in the numerator.